Now, let's look at the example which we have. Consider the sequence 8 is to 18 is to 30 is to 44. Let's write it here. We are given the sequence 8 is to 18 is to 30 is to 44. Now, we are looking at our quadratic sequence, if you still remember from the previous video. Now, write down the next two terms of the sequence. So, in order for you to understand or to answer this question, this is a straightforward thing. I'll give you method number 1 and I'll also give you method number 2. So, method number 1 is to understand that, okay, what do we know about a quadratic sequence? A quadratic sequence has a second constant difference. So, which means now we need to have our T1, T2, T3, as well as T4. And in order for us to find a difference between the two terms, we always have the T2 minus T1, or the term in front minus the previous term. So that will be 18 minus 8, which is your 10. Then your 30 minus 18, that will be your 12. Then 44 minus 30, that will be your 14. Then that is going to be our first difference. But we know that a quadratic sequence has a second constant difference. So that will now come for us to solve this first sequence which we have, so that we can give the second constant difference. So that will be 12 minus 10. That's going to give us our 2. And also, of course, 14 minus 12 is also going to give us our 2. Which means that our constant second difference is always going to be 2, 2, 2, 2, because we know that that's how we calculate and solve for quadratic sequence. So, of course, which means whatever we're going to have here, we're going to subtract here. We should have the second difference, which is 2. So that will be 14 plus 2. 14, let's use a different marker over there. So that will be 14 plus 2, that's 16. Okay, then in order for us to get the following term here, that will be 14 plus 16 over there. Okay, so that will be 44 plus 16, and we get 60 over there. So which means now we have the following term. Again, we start here from the constant difference, because we know that all the constant difference of a quadratic sequence, they are all the same. So again, here our constant difference is going to be 2. So that will be 16 plus 2. Then we get a 18 here. Then 18 plus that 60 there. So that will give us 17, 70, 78. Why? Because we know that we can calculate this by this process. So in order for us to get the missing two terms, which we were looking for, as they say, the next two terms, the next term is going to be 60 and 78. How did we do that? We first calculated the first difference, then we calculated the second difference, because we know that the second difference is constant of a quadratic sequence. Then now we can now deduce that, okay, now that this is the same constant difference which we have, which is 2, 2, 2, 2, which means we can start from here. So 14 plus 2, which is your constant difference, is going to give you this 16. Then of course 44 plus 16 is going to give you the next term. Then again, you go again down here and start from the constant difference, because we know that the difference of the constant difference d of a quadratic sequence, it's always the same. Now again, it's 16 plus 2, then you get your 18, then again 60 plus 18, then you get your 78. So that's how we do. If they say the next three term, again, you're gonna come back here and you have your constant difference, which is 2, then 18 plus 2 is 20, then 20 plus 78, that's gonna be 98, and etc. njalo njalo. So that's how we can solve that question which we were given the first question. Now they say that determine the nth term of the sequence, which means they want you to determine the general term, which is Tn is equal to an squared plus bn plus c. So this is the general term which we want. And how do we calculate this? We know that we can calculate this by first, this is your first number 1. We know that 2a is equal to d. What is d? D is our second constant difference. So since d is our second constant difference, then now this is making our life easier, because we have already calculated the second constant difference. In this instance, it's 2. So that will be 2a is equal to 2. Then we solve for a. Then your a will be equal to 2 divided by 2, because you divide both sides by 2. Then your a is equal to 1. That's your first step. Number 2, we calculate the value of b. We say that 3a plus b is always supposed to be T2 minus T1. What is your a? Your a, you have calculated it already. It's equal to 1 over there, plus b is equal to T2 minus T1. What was our T2? Our T2 initially was given as 18. Our T1 was given as 8. So that would be 18 minus 8. Then after that, we solve for b. B is equal to 10 minus 3. Then your b will be equal to 7. Now we have the b value. Now we want to calculate the value of c. That will be now point number 3. So that will be your a plus B plus C is always equal to T number 1, which is your first term. What is our A? Our A we have calculated it to be 1. And what is our B? Our B we have calculated it to be 7 plus C, which is our variable which you need to calculate there. And what was our T1? Our T1 was given as 8. Then we make C the subject of the formula. So C will now be equal to 8 minus 1 plus 7 is 8. 8 minus 8 is equal to 8 minus 8 is equal to 0. Then therefore we can see that our A is equal to 1, our B is equal to 7, and our C is equal to 0. Now we can now substitute into the general Tn formula, which is Tn is always equal to An squared plus Bn plus C. What is our A? Our A is 1, so that would be 1n squared plus, what is our B? Our B is 7n, and our C is 0. So then therefore our Tn will be equal to n squared plus 7n. That would be our general term. Easy and straightforward as that. I use this one in this instance so that you guys don't remember, don't forget that, okay, maybe in another question your A value is going to be 5, which means that here is going to be 5n squared plus 7n. Even the C value I put at 0 now, just for now, so that you know that they need to be the value of C. So in another question which you'll be given, maybe the C value is going to be 8. So again, you substitute there and put the 8, then you can be able to be good to go. Now the other question which is always asked when you're looking at that, they say that hence calculate the 20th term. It's always these questions, they are always like this. These are the 4 questions which you can always expect when you're looking at this quadratic sequence. So when they say now calculate the T20, which means that now, okay, now we know that we understand and you've calculated your Tn, which is Tn is equal to n squared plus 7n. Now they want you to calculate the 20th term, so which means they want T20, which means now where there is n in your general term, now you're substituting with the 20, so that will be 20 squared plus 7 multiplied by 20. Then of course you use your calculator. Don't try to break your mind and try to think a lot, because of course if you do that you get a wrong answer. So that will be 20 squared plus 7 times 20, and I'm getting 500 and 540. So that would be your Tn. Then 1.4, the last example which we have over there, they're saying which term in the sequence is 330. Oh my word, how do you see that? The moment say which term in the sequence is, which means that they've already given us Tn value there. So we know that our general Tm was Tn is equal to n squared plus 7n. So when they say which term in the sequence, which means we need to calculate the value of n, and we have already been given our Tn to be 330, which is now equal to n squared plus 7. And now we have to calculate the value of n, and we know that that will be minus 330. Then after that we can now calculate the value. So in this instance you can find your factors of n, which is just easy. Again, your n will be like your 15 there, and another n will be equal to positive 22, then minus there. That's through factor format. So then your n will now be equal to 15, or your n is equal to negative 22. Of course, then you can finalize that the n can never be negative, so then therefore your n will be equal to 15. If you don't know at this point how to find the factors as I did here, don't worry. That's why we have what we call the quadratic equation. We know that x is always equal to our quadratic equation says that x is always equal to negative b plus or minus square root of b squared minus 4ac over 2a. But in this instance, we are dealing with n. Your n will be equal to, so we know that this is your a, this is your b, this is your c. So now we can just substitute in here in the quadratic equation. Then after that, you can get the values. So that's the example which I have, which deals with quadratic sequence. Dango means thank you.